the most important thing about programming is to think rationally and logically the steps how you are going to solve whatever problem you are trying to solve using a program, or whatever program you are aiming to write, whatever it wants to achieve. Okay, the steps rationally and logically. Now, if we are new to programming, generally what we do is we tend to mix up steps, or tend to combine lots of steps. Whereas in programming, we have to break it down into small steps, which does some specific things and all. So thinking in those terms, developing that's the most important thing. And as I was saying, syntaxis is something which you can pick up from books, pick up from anywhere. Okay, so learning one language and learning another language. If you have learned one language, then learning another language is not very difficult. Okay, but learning any one language for the first time, that's the most important and difficult part. Okay, so what I'll do is, and mind it, this is going to be a very beginner's thing. Okay, so I might just start with things which you might find very elementary, but um, I got to, you know, have a little patience. First thing is that um, a little bit about what is a program. So essentially, a program is a set of steps, which the computer is going to follow sequentially to solve a problem. So that's a problem. That's a program. Set of statements. So this one is a statement. This one is a statement. This one, every one of them is a statement. Okay. So a set of statements. Now, um, most of the computers that we know as of today are the digital computers, which um, understand only a binary language. Binary language means a 0 and a 1, only two things, 0 and 1. So these statements have to be in 0 and 1. Okay. At the end of the day, all these statements have to be a series of zeros and ones. And these statements also use some data. So the data would also be a sequence of zeros and ones, which generally uh, is inside the program. Okay, or is incorporated into a program, as we'll learn later, from hard disk or any other storage medium or input device, the keyboard or mouse or whatever. So the language that the program has to be written for the computer to execute it, the digital computer to execute it, has to be the binary language, zeros and ones. So the first computer language that was developed, first generation language, was exactly this machine language. zeros and ones. So if you were a programmer in the late 1940s or early 1950s, you would be actually writing programs using 0 and 1. They were done using something called the punch cards. Absolutely. Very difficult for um, anybody to even understand what's going on. Okay, but the programs were simpler, and they could do a little bit of work like adding and subtracting and all that, and they could be still programmed using zeros and ones directly. You uh, feed feed the program, feed a series of zeros and ones into the machine. How? Let's not get into that. You can just ignore it for the time being. But since it's very difficult to understand, very difficult to even write programming zeros and ones, and then understand what's going on and what has been written. If we want to um, change the program or need to know what the program is doing, so it was absolutely almost impossible to do that. So then came the second generation language, called the assembly language. This was quite human-like, a little human-like, not very human-like, but at least it used English words. Okay, this one did not use anything, any English, Hindi, or no language, no human language. It was simply zeros and ones. So if you wrote a program in machine language, you would have to write series of 0, 1, 1, 0 like this. Okay, all your instructions would be like this, right? But nobody would understand what exactly is happening. So the second generation language, the assembly language came, which um, at least had some uh, English-like words. For example, um, it would have a command called INC, a statement commands or word or keyword called INC, which stands for increment. It would have something called add, which adds two things, two numbers. Okay, so at least it had some um, English-like words. So you could at least look at a assembly language program and read it in English. So it was readable, but still it was very difficult to understand what was going on, because this, at the end of the day, these instructions were instructions directly for the CPU. So the computer has a CPU and it has the RAM, and it has the hard disk drive, and it has the IO devices, input output devices. So this would directly be instructions to the CPU, and although it had English words, it still didn't make much sense if you wanted to figure out what's going on in the program, what exactly is the program doing. Okay, so that's when came the third generation languages, like all the languages that we see nowadays. Okay, like COBOL, it's not longer much used nowadays, of course. C, which is still there, and till Python took over a few years back, C was the largest used language. C++, um, Basic, or Visual Basic, or Java, and Python, and a host of other um, languages that you see. Now, um, here in these languages, they were very, very English-like, very much English-like. Okay, some of them absolutely very close to English, like Basic and Visual Basic. Um, some of them written in a very cryptic, although English, but very cryptic, like C, C++. Okay, and then we have something called fourth generation language, also fourth and the fifth generation language, like SQL is a language which is a fourth generation language, which is very much English like, and like this is used for um, dealing with databases, I mean relational databases, RDBMS, relational database systems, putting data, retrieving data from databases. So difference is between fourth and third is that in third generation language you have to do how to do. Okay, you have to tell, you have to write steps, you have to tell the computer how to do it. Whatever you want to do. Suppose you want to do some task T. You just have to tell how to do T. Okay, how? Okay. And here in fourth generation language you don't need to tell how. You just need to tell what to do. So um, um, the lines of code in fourth generation language is much less. In third generation language you have to write every step of how to solve a problem. Okay, to give an example, if I have a um, let's say if I have a some database, and I just imagine that it has some a table, lots of rows and columns. If I have to get data out of this table using a third generation language, I have to tell, okay, um, suppose I have to read this table. So this table has some whatever number of rows and columns, and I have to get data for, let's say, all the rows and columns of this table. I have to write exactly each step, how to fetch data from this point, I mean each cell of the table. Just think it's an Excel file. Okay, just think about like that. So I have to write the program in such a way that I have to tell that pick this point, pick this point, pick this cell, this cell value, this cell values, so on and so forth, and then go to the next row and pick this and this and this. And that would be the third generation language. If I am writing it in any third generation language, doesn't matter which. In a fourth generation language, if I am using SQL, is pronounced as SQL, structured query language. So here I just need to write a statement that says select star from whatever is this table name. Okay. Just one line of code, and I get all the data out. Okay. So I don't need to tell how to get the data out of this table. I just need to tell what I need from that table. Okay. If I'm doing it in Java, C, or Python or whatever, unless I'm using a library, okay, because Python libraries internally do lots of stuff, makes your life easy. But otherwise, you would have to write loops. So there will be many lines of code. Getting data out of this table will be many lines of code. Okay, so that's what makes the difference between third and fourth generation languages. So we'll just forget about the fourth generation language for the time being. We'll concentrate on a third generation language, Python. Okay. Now, the thing is that at the end of the day, the um, computer understands only binary. Okay. So if you had written your program in a first generation language, 00111, it would be directly understood by your computer and executed. If you had written your program in a second generation language, the assembly language, then this is English like. Computer doesn't understand English. These statements like add, uh, R1, R2, something like this, if I write, this is the very much English like. This CPU would not understand, right? So this has to be converted. This statement written in this language has to be, at the end of the day, converted into some sequence of 0, 1, 1, 1 or 0, whatever is an equivalent sequence of zeros and ones, so that this can be then executed by the computer. So this process is done by another small program which converts this assembly language into machine language. This is machine language. This is machine language. Not machine learning, mind it. Nowadays ML means machine learning. No, we are not talking machine learning right now. Okay, ML, machine language. I might just put a slash in between so that we distinguish between machine learning and machine language. Okay, so it has to be converted. So this conversion was done by a small program called assembler. It would take these data, these program codes, and convert them into zeros and ones. Okay, and this was called the source code, and this is your executable code. So the program that you write in your whatever language, these are called high level languages. Okay, these are all high level languages. Barring the first generation, second, third, fourth, these are all high level languages. Okay. So if you write your program in a high level language, it has to be converted into a low level language, machine language in fact, and the program that you have written is called the source code, and it is converted into zeros and ones, which is the executable code. If you have written your program in a third generation language like Python, okay, whatever you write, for example, you write a equal to 10, a b equal to 20, and c equal to a plus b. This is a very English-like language you have written a Python program to add two numbers. Now, um, this is the source code. This has to be converted into executable code, which is 0 and 1. And that is done by a program. It is called either a compiler or an interpreter. I will talk about that shortly. Okay. So compilers and interpreters are small programs themselves. They are programs themselves which take source code which is written in high level language and convert it into machine level language, machine language called the executable code. Now, one of you had asked the other day the difference between .py and .pyc and .pye files. I think Nitil had asked. So the difference is that this is generally the file that you write in Python directly, the raw source code files. Okay, and PYE are fully converted executable code, and PYC, I'll come to it shortly, is something in between. It's semi-compiled, partially compiled. Okay, now compiled or converted. Okay. Now I will talk about this process of what a compiler does and what an interpreter does, and a little bit about these things. Okay, this is a source code. This is a complete executable, and this is what is sometimes known as bytecode or P code. The thing is that your source code can be converted into executable by two ways or two methods. One is interpreter, one is compiler. Let me first discuss what a compiler does. For example, you have written your program statements. This is your source code. You save it to disk. On the hard disk, you put this file. Somewhere on the hard disk, you save this file. Then what you do is you run a small program called the compiler, which converts this source code into executable code, zeros and ones, and save it to disk. Okay. Now this code can be run again and again by the CPU. Okay. It is compiled only once. So you write your program. If you want to make change in your program, you have to compile it again. Okay. You make some changes, add some more lines or delete more lines or modify some lines, and then you compile again. You modify the source code, you convert it into executable code, and the executable code is there permanently on your hard disk. And every time you want to run your program, you just run this, the executable. Okay. The machine understands these zeros and ones, and it's there on your hard disk, the set of zeros and ones as a file. Okay. You can run it however many times you want. Okay. For example, um, you all might be using some word processor like the MS Word. So MS Word has a has an executable file called the word.exe. So word.exe would be a file which is residing on your hard disk somewhere, and whenever you want to run MS Word, you run this exe, this .exe, word.exe. Okay. Now this is one type of way of doing things. Lots of languages are of this compiler type language or compiled languages, what we call compiled languages, like C, like C++, like which one? Mm, I'm forgetting. Yeah, like the older languages that we had, COBOL, like um, I'm forgetting the older languages that were there, which were all compiled languages. Now, as against this, there is another way of doing things, the interpreter way of doing things. So this is so a compiler would be a small program which reads your source file, converts it into zeros and ones, saves it to disk, and every time you run this file. Interpreter works in a little different way. So you have your source file, source code, which is residing on the hard disk somewhere as a file. This file is there in the hard disk, and on the hard disk there is a small program, the interpreter, and what it does is every time you want to run your program, the interpreter converts your source code line by line into zeros and ones. So each line is converted into zeros and ones and fed to the CPU, fed to the um, machine. Okay. So the conversion happens on the fly. Conversion happens what is known as runtime. When you want to execute your program, this source code is converted into zeros and ones. They are not saved. This converted program is not saved on disk. Okay, it is not converted and saved on disk. No. The interpreter reads the source file, converts it into zeros and ones, and directly feeds it to the CPU. Okay, the CPU executes it. It picks up the next line, converts it into zeros and ones, feeds it to the CPU. CPU executes it. Okay, and then the program runs. The whole program ends, the zeros and ones vanish. Okay. So the interpreter converts source code into executable code every time you want to run your program. So mind it, this interpreter itself is a program. So it also has to run on the CPU so as to convert your code into zeros and ones. So this slows down this your program a lot, because every time you run your program, the interpreter has to convert it into 0 and 1. The zeros and ones are not saved, and it takes time to convert. This English like language, whatever you write, it takes time. Each line takes time to convert into zeros and ones into machine language, right? So that makes interpreted languages. Some languages operate as interpreted, like Python. The first one was actually basic. Okay, and Visual Basic, and let's say Java, and a host of other languages, lots of other languages. That's why these are slow languages, because if you write a program in Python um, and you run it, for example, if I just run whatever, if I just write a is equal to 10, b is equal to 20, c is equal to a plus b in C, and if I run this program, let's say this is my source code, so I'll save it. My first example. So this is the source code. So if I just go and see, this file is created on hard disk. If I just open it in Notepad, just a text file, simple text file. Source codes are simple text files. Any language, whichever language you write. Okay. Now there is no other file here. Now if I have to run this, if I just want to run this particular program, if I run it like this, it has run, given some output. What it has done is, there is a Python interpreter which converted these lines of code into zeros and ones and executed them. Now if I run it again it will convert all these lines of code into zeros and ones and execute them. This makes Python programs very slow. Whereas if I had written this program in C, then C would have converted, the C compiler would have converted these lines of code into zeros and ones, saved it as a separate executable file, 0 and 1 file called executable file, and I would execute that file again and again. It saves time. It makes C programs or C++ program much faster. Okay. Now one of you had asked something. Louis, have asked more details on direct Python. More details on direct Python.py file. Is it normal Anaconda coded file? Anaconda is a package manager. It's just a manager program which helps manage various things related to Python on your machine. So Anaconda is a manager program. Okay, so there is nothing called Anaconda coded file. Or Anaconda is not a language. Got it?
Okay, sir. Yeah, I just saw this file that you saved. Even this was .py.
Hmm.
So basically, all the Anaconda programs like Spider or Jupyter, these will be .py, right? I'm understanding right.
Um, just a little different. If you write the program in this thing Jupyter Notebook, it creates a IPY. Okay, IPYC dot IPY. Okay, so that is a little different. I'll come to that. Okay.
Okay, sir.
Now the thing is that we understand that interpreted languages would anyway be slower than compiled languages. Right, Nachiket, you understand? Why interpreted languages would be always slower than compiled languages?
Yes, sir. Yes, sir.
Right. And it's, I mean, really, what should I say? I mean, ridiculous. If one thinks about it, an interpreted language is a ridiculous language. Okay. Um, why? Because why do I need to convert it into again and again zero? And every day, suppose I have written a source code. I have written this same program, this program. Okay, this thing, this is the source code. Now suppose this program I don't want to change in my whole life. So I should be able to convert it into a set of zeros and ones and keep it. And every time I want to run this program, I'll run that set of zeros and ones. I'll run that program. It makes sense. Why should I every day and every time I run this program, why should I convert it again and again to zeros and ones? Okay, and run, and then all the zeros and ones I discard. I put them to dustbin. Okay, so interpreter and interpreted languages are really obnoxious, ridiculous languages and slow languages. Now, because mind it, if I dig a little bit deeper, what happens is like this. Let us understand. So this is your hard disk, and in the hard disk you have a source file, source code, some lines of code. You also have the interpreter. Interpreter is actually compiled. It is zeros and ones. This is fully compiled code. Okay. And you want to run this program. What will happen is, if this is the CPU, first the interpreter will run. These zeros and ones will run. Okay, first these will run. So it will take CPU time because this program is running. The interpreter itself is running. Okay. Then what will it do? What does it do? I mean, it is running, but what does it do? What will it do? It will read this source code into RAM. The source code from the hard disk will be read into RAM. Okay. Then these will be like, if this is the RAM, then first from the hard disk all these source codes will be picked up and read into RAM, filled into RAM. Then each one of these lines, one by one line at a time, will be picked up by the interpreter, converted into a 0 and 1 in RAM, and then put into the CPU for execution. Okay. When this line is finished, the interpreter again runs on the CPU, picks up the second line from RAM, converts it into zeros and ones, executes this line in the CPU, and this goes on and on. So you see, alternately, what is happening is the interpreter is running, converting your source code into one line of executable code and running. Then again the interpreter is running and converting the next line, and so on and so forth. So you see that this process itself is this is a second way in which it slows down your execution. Okay, these interpreted languages. Okay, and these zeros and ones, since they are not saved back to disk, once they are run in the CPU, they are discarded. Okay, since this is such a nasty way of doing things, some of these languages like Java and VB and also C sharp or C hash and a few other languages, they came out um, with a solution, with an in between solution. Okay. What they do is, if this is your source code written in either Java or VB or C sharp, whatever language you have chosen, one of these languages, and um, Python I will actually keep outside this. Okay. So the source code, which is in English, is converted into what is sometimes called P code, or also called bytecode sometimes. This is neither fully English nor fully zeros and ones. It is partially compiled. Partially compiled. Okay, partially compiled code here. And when you want to run your program, then it does not have to convert the source code into zeros and ones, the executable, from scratch. It just converts from these partially compiled codes into fully compiled zeros and ones, and that goes into the CPU for execution. Okay, so some of these languages, these were all interpreted languages. Java, VB, C sharp and Python, these are all interpreted languages. So they have evolved a way of making them themselves, I mean making their programs written in that language run faster by this mechanism, that they convert the source code into partially compiled code, and when you run your program, they don't pick up from here, they pick up from here. So part of it is already compiled, rest of it is compiled and put into zeros and ones, I mean converted into zeros and ones, and then it is run. So this makes it faster. Okay. In fact, languages like C sharp and VB, they produce quite extensive compiled codes. These partially compiled codes are very extensively compiled. Very, let's say 80% or 90% of it is compiled. Only 10-20% is left. Okay, so that's why they are quite fast. But still, they are not fully compiled languages. Now, what about Python? Why have I kept Python out? Now, Python has its own way. For example, I'll just show you. I have this file, right? exp1.py. If I have to run this program, if I double click this program will not run because this is not an executable program. For example, in your machine, generally what you do, if you have to run Excel or anything, for example, let me see where there might be somewhere, Excel might be somewhere. Let me just check. Yeah. So Excel, the file excel.exe is a executable program which is residing here. There is a program called excel.exe on my hard disk. This is fully compiled. If I open it in Notepad, let me see if I should. I should not open it in Notepad because it's huge. It's 64 MB. It will take a lot of time to open. But if I open it in Notepad or any other text editor, you'll just see a gibberish, zeros and ones. I mean, you would not see zeros and ones because you have opened it in a text editor which tries to interpret the zeros and ones as some kind of text. Okay, but you would not understand anything. This is the executable. This is the actual file, and if you just double click it, this runs. Excel opens. Okay. So executable codes are what you can execute directly. Okay, the Excel MS Excel program runs. Okay, but here I don't have an executable program, right? Then how do I run it? So let's say if I want to run it, let me just try to run it. So let me just first go to this particular folder where this file is. So I have just this one file, and if I want to run it, I will run it like this. I will ask python.exe to run, and I will pass the name of my program as a parameter, and just see it runs, and just see there is that print 30. Okay, so python.exe is the interpreter. Python.exe is the program which converts my source code into executable code and runs it. If I run it again, it again does the same thing. It converts it into zeros and ones and runs it. Python.exe, I have to call python.exe and pass my program name, my source code as a parameter in the command line, and Python will run my program, convert my program into zeros and ones, and then run my program. Okay. So this is what happens, right? Now, as I mentioned, some of the languages have taken some advancement. This Python script that you saw here, simple text file opened here, right? Plain English. And every time I run it, it will be compiled and executed, and the zeros and ones will be lost. Now Python sometimes does a trick, sometimes. Okay. For example, if I open another program, let's call it um, exp2. Okay. Here I write import exp1. Okay, and just that. Okay, and run this from here. Okay, now I go back here and I see that a folder has been created, underscore py cache underscore. Inside that folder, a file has been created with a bizarre name, which starts with exp1 and has the word .cpython -37.pyc. This file has been created. If I open this file in Notepad, what I see is some stuff which I don't understand and some stuff which I understand. Okay, some part of it is in English and some part of it is not in English. This is the what I was referring to, the bytecode. So sometimes if you make any library in Python, the library source code is partially compiled into these P codes or bytecodes. Okay, so that's Nitil was there. Nitil wanted to know, but he has left. I had told him that I will explain the difference between .pyc and .exe and .pye and .py in more detail. This is what I wanted to show. So .pyc is partially compiled um, version of exp1. So this is my source file exp1. I can open it here. I can open all the two files, both the two files. exp1, this is the source code, and I will open its partially compiled version also. Okay, let me see if I can open it. Yeah, it will actually destroy the file, but anyway, let me open it. Okay.
So looks like your comments has remained as English, and non-comments, which is actual instruction, has been changed.
Uh, uh, that's one, and apart from that, a few other things as well, because this thing is nowhere,
Yeah, directory.
right? So these lines definitely converted and few things added. Comments, these are excluded. These are comments, so these are some of it is excluded. I don't know. Okay, yeah, they have just remained. Just give me a moment. Okay, just give me a moment. Sorry, um, I just had to attend a call. So anyway, so we see that part of it, comments obviously, part of the comments, they just kept it as plain text, added a few other things, and I will not save it because that will destroy the file, and part of it is compiled. Okay, so that's what are these P codes or um, bytecodes files. Now, but still it is slow because it's not fully compiled. Before running, Python has to convert this into absolute zeros and ones. It's still slow. So if we want to convert it fully into executable zeros and ones, like any other executable file, um, we have a few Python compilers that have come out. One is Py2exe, and there might be a few more. I don't recall right away. Okay, they have their issues. Some of them have some issues and this and that and all that. Okay, but those programs, I mean those compilers can be used to convert this .py file into fully zeros and ones. So suppose um, I use a Py2exe to convert one of these source files into zeros and ones, then I don't need to um, run that program using Python space the source code name. I can directly write the program file name, and it will run. Okay, it will be faster, much faster, because it's already compiled. All the English has been converted into zeros and ones and stored once and for all. Okay. Now, so that's the basics about the two broad ways of methods by which these languages convert your program code into, I mean, source code into program code and run. Okay.
So
So
like
I hope, yeah,
like
yeah,
pi to exe, do we
yes.
have reverse exe to pi?
No way, no way. You cannot have.
Okay.
You cannot have. Disassembler is there. I mean, assembly to machine language is there. Machine language back to assembly is there. But I mean, word to PDF, PDF to word is there. But once something has been converted into zeros and ones, then only God can figure out what it is.
Okay.
Okay. I understand where you're coming from. You still are thinking about that particular file you have been
Correct. Correct.
you guys have been dealing with. Trust me,
Correct.
you don't need to decompile or do this is called decompilation. Okay,
Hmm.
and yes, um, decompiling disassembling is possible. Disassembling, converting back my zeros and ones back into assembly is possible, but not completely back into English or any some language. Okay. Um, if it is fully executable. Okay. Some languages, if I remember vaguely, okay, if there is a byte code, then it can be um, converted back into source, some kind of source. Um, I just need to, or I might be wrong because this is something which I vaguely remember because nobody really does that or wants to do. I mean, everybody wants to do that, but nobody can do that unless you know they can understand assembly. Then any code written in any language can be converted back into assembly language. Okay, so if it is in zeros and ones, it can be converted one step back. I mean, if you have written something in third generation language, which has been compiled into zeros and ones, which is a first generation language, machine language, then from machine language it can be brought back to second generation language, assembly language. Okay, and uh, those who understand assembly language, they can then uh, uh, understand and change and do all kind of stuff. But trust me, if you write a program with just 5 lines of code in Python, that will be at least 500 lines of code in assembly. Okay, so understanding that is even a nightmare. But no, pi to exe is there, but exe to pi, no. Okay, so now this is done. Now let us get to some logic development, because we will be writing programs which are the source codes. We will be choosing one of the languages, Python. Right. Now, so a program, as I mentioned, consists of statements, sequence of statements. Okay. A statement actually consists of one or more of the 4 components. These are statements. Of statements. A statement or a program statement consists of 4 things. One is keywords. Keywords are specific to each language. Okay, every language has its own keywords. Keywords are words which that particular programming language interpreter or compiler understands, has a special meaning to the compiler. Okay. So if I am writing program in Python and I write if A greater than B, this if is a keyword. It's a word, it's an English word, and it's a keyword. Why it's a keyword? Because Python interpreter, Python is not a compiler, Python interpreter has a special meaning. It understands this thing, this word. It has a special meaning. This if, the word if has a special meaning for Python. Okay. So statement consists of keywords, one or more keywords. It has one or more variables. Not one, it may be 0 or more variables. It may have some operators, and it would have, may or may not have some constants. One or more of these 4 things would be there in a program statement. So if you just look at it, if A greater than B colon, this is a keyword. These are variables. This is an operator. These are operators. In fact, This actually, this thing wouldn't fall under an operator. Just need to check. It's a syntactical thing. I would rather classify them as a keyword, this colon. Okay. So what is the keyword? Keyword is a word which has special meaning for the compiler or interpreter of that language. What is an operator? Operator is a symbol or a sign or entity that operates on entities associated with it. It may be the associated entities might be variables, they might be constants. For example, if I write 10 plus 20, so this is a constant, this is a constant, this is an operator, and if I write a equal to 10 plus 20, so this is a program statement. There are no keywords here. There is a variable, there is one constant, another constant, and an operator. This is a constant, this is a constant, this is an operator, this is an operator, this equal to is also an operator, and this is a variable. There are no keywords. So operator is something which operates on entities. Entities means it can be a constant, it can be a variable associated with that operator. For example, this plus operator operates on these two things, these two entities, 10 and 20, these two constants associated with this operator. Okay. Now, that constitutes this whole thing constitutes a program statement. This one constitutes a program statement. So we have operator, we have keywords, we have constants. Constants are values which don't change during the running of the program, during the runtime of the program. So some values which don't change while the program is running, they are known as constants. Some values might change while the program is running. To store those kind of values, we have symbols which are known as variables. Variable is a representation of a value. It's a representative of a value which can change. For example, a can be 10 plus 20. In the next line, a can be 10 minus 30. Okay. So variables are entities whose value can change during the running of the program. But 10 will always be 10, 30 will always be 30. Okay. So in RAM, what happens is, if this is the RAM of your machine, and in your program, if you have written something like a equal to 10, a is a variable, this is an operator, 10 is a constant. In a RAM, a small place is reserved. A small place in the RAM is reserved. That place is given a name, A. Okay. And the value 10 is filled inside it. Okay. So variables are small places inside the RAM. So whenever you declare a variable, whenever you put a variable in your program, there is some small space reserved for that variable in RAM, and this value can change. And suppose my program statement, this is my program. A equal to 10, in the next line I write A equal to 20. So this can change. In the same place where there was the value 10, now the value 20. So program, when it executes, first it will execute this line. This is line number 1, this is line number 2. Okay, so just 2 lines of code. A equal to 10, A equal to 20. Just 2 lines of code, nothing else. Okay. If I run this program, what will happen is it will not print anything. What it will do is, first it will create a space in RAM, give it the name A, into which it will fill the number 10, and then the second line will execute the same place A will be filled with the number 20. So A is called a variable. Why? Because A can hold different values which can change during the running of the program. Got it? So you have a program statement which consists of one or more of these 4 things: keywords, variables, operators, and constants. Okay. So now we understand that a program is a sequence of statements, and each statement consists of one or more of these things, 4 things. Each programming language would have its own special keywords, which has special meaning. For example, if I write for, okay, are in range 10. This is a program statement. In this program statement, there are 2 keywords. For is a keyword, in is a keyword, r is a variable, range actually is a function. Okay, it is another statement actually. I mean, not another statement, called a function. It's a function. Okay, which evaluates to. I'll not go into details because otherwise you'll get concerned. Confused. So I just wanted to show that there are other keywords like for, in. There are lots of keywords. So every language has these keywords. Okay. Now we'll start into logic building. To solve a problem, you have to think, as I say, in a sequence of steps that you would do to solve that problem. For example, let us consider this problem that let us take the simplest one. Okay, out of 2 numbers 10 and 20, write a program. Note carefully what I am writing. Okay, I am not asking you to take the numbers from anywhere. Okay, mind it. Just see what I am writing exactly. Write a program that compares two numbers 10 and 20 and prints the smaller number. This might be a very stupid program, the stupidest program ever, but this gives a flavor of how you start thinking as a programmer. Okay. So write a program that compares two numbers 10 and 20. Mind it, I'm not taking the numbers from the user or from any database or anywhere. This problem statement, the program problem statement, is very straightforward. Okay. The numbers themselves are embedded in the program. So write a program that compares two numbers 10 and 20 and prints the smaller number. Okay. So let us write its pseudocode and flowchart. So we'll introduce you to two things. Pseudocodes and flowcharts. Remember, when you write a program in a programming language, in some programming language, whatever programming language, first generation, second generation, whatever, third generation, whatever programming language, when you write a program, that means you write a series of statements in that language. It's either a source code, or if it is compiled, if the source code is compiled, it's an executable code. Either a source code or compiled into an executable code. Okay. And the source code would definitely have to be in the language you have chosen to write the program. C, C++, Java, Python, Fortran, Pascal, whatever. Okay. Some of the other programming languages are just coming back to my head now. You have this third generation languages like COBOL, Pascal, and Fortran, which are all compiled. Anyway, so when you write your program source code, when you write your source code, you would choose some language, some programming language. And it will be a programming language, right? It has to be one of the programming languages that are there in the world. There are at least 120 programming languages now, or more than that. Okay. But pseudocode is a code, or is a sequence of statements, is a program which is written in a very English-like language, which is written not in any particular programming language, but just in a simple English-like language to express, to specify what are the steps you are going to take to solve the problem. For example, here the problem statement is write a program that compares two numbers. So, the third thing I'm going to introduce you is the algorithm. Okay, so I might just put it like this. First thing that I'm going to talk about is the algorithm. An algorithm can be expressed or written either as a pseudocode or as a flowchart. So an algorithm is the set of steps that you are going to take to solve the problem statement. This is my problem statement. So what steps I'm going to take, in which manner, in which way, that is what is known as an algorithm. The algorithm can be written either in a very English-like language, not any particular programming language, but just like simple English language. And when I write that in a very simple English-like language, then it becomes a pseudocode. Or the algorithm can be written in a pictorial form. Okay, some kind of pictorial form. So if I write the algorithm in plain English like statements, then it's called a pseudocode. If I write the algorithm in a pictorial representation, in some kind of graphical representation, it's called a flowchart. For example, this problem that I have written, the algorithm, first I'll put it in a pseudocode. What will be the pseudocode? First is, let us look at the problem. Write a program that compares two numbers 10 and 20. So there has to be two numbers 10 and 20, and if there are two numbers, the program has to store those two numbers somewhere, right? So the pseudocode would be first step is take a variable name whatever, say x, and store the number 10 in it. Number 2, take a variable, not name, take a variable, I'm just writing it in a little shorter form. Take a variable, as we know, variables would be given some name, right? So take a variable y and store the number 20 in it. Third, check if x is greater than, I will not use any symbol, it will be entirely English. Check if x is greater than y, then print what are we supposed to print? Print a smaller number. So print y, else print x, stop. As simple as this. And flowchart, if I want to write the flowchart of this program, now to write flowchart, we have to learn a few things, like writing flowcharts has some specific diagrams that we have to use. For example, a program starts with a ellipse, then work, wherever some work is done, it's a rectangle. For example, I do in a first step, what do I do? In fact, there is a zeroth step actually. Start the program, start or whatever. Take a variable x and store the number 10 in it. So it is written something like this. Take a variable x and put 10 into x. So flowchart, writing flowchart has these few things, like what type of diagram to use for what. Next step, take another variable, and then this arrow indicates that the program flows from here. It does this thing, then it comes to the next step and it does this thing, puts the number 20 in y. Then the next is it has to check. Checks are always diamond shaped elements. Is x greater than y, and it has two outputs, if yes, if no. So we have to print the smaller number. So if, what are we checking? Is x greater than y? Then y is smaller. Then what we do is print y. Is x greater than y? No, that means x is smaller. Print x. And then both of these should come, and somewhere here I'll just put it here, stop. So this is how a flowchart is written. So developing flowcharts is the first step in building your logical reasoning abilities or programming logic building abilities. Okay. For example, second problem. Print all integers from 1 to 5. So this is the second problem. What would be the pseudocode? A nice pseudocode would be that you have a variable a which you have which you put the number 1, you have a variable b where you put the number 2, you have variable c where you put the number 3, you have variable d where you have put the number 4, and you have the variable e where you put the number 5, and then in the next step you print a, in next step you print b, and so on and so forth. Or instead of putting it in variables, another pseudocode 1 and pseudocode 2 would be, directly print, don't store it in a variable, print the constant, print 1, print 2, and so on to print 5. Now both these are bad, both these are inefficient. We will write another pseudocode 3, when we learn loops. Pseudocode 3. When we learn loops, we'll write take a variable a, put the number 1 in it. So sometimes we don't write the entire English sentence. For example, here I said write the entire English sentence. Take a variable x and store the number 10 in it. Instead of that, we can simply write like here a is equal to 1, or like here x is equal to 1. Here I am writing a pseudocode which will be very much actually Python like, not just Python like, this is also very much C like. Okay, just that I have not written the entire English sentence. So take a variable x, put the number 1 in it. Next step would be print x. Next step would be add 1 to x. Next step would be check if x greater than 5. If yes, stop. If else, go to step 2. Okay, so this creates a loop. Loop means a set of statements which repeats again and again. Okay, if I write the flowchart, all the 3 flowcharts, this flowchart would be written something like this. Start, and I can combine all these steps in one. These are all work statements. I can combine all of them in one work box. In flowchart, we don't use the equal to sign, we use this arrow, and arrows are always pointing from right to left. Means variable is always on the left side. Variable is always on the left side, and whatever value we put into the variable, so we indicate 1 I am putting in a, 2, 3, and so on and so forth. And then print statements are these parallelograms, not squares or rectangles. These are parallelograms. Input output statements. Print a, then, or I can write all of them together in one print box. Print B, print C, print D, and then stop. So this pseudocode converted into a flowchart. Now this pseudocode, here I don't initialize these, or I don't use these variables at all. I simply write print 1, print 2, print 3, and so on and so forth. So if I write pseudocode for, a flowchart for this, pseudocode 2, it will be like this. Start. After starting, the program will flow and it will print all these. Print 1, print 2, print 3, 4, 5, and then stop. And then this one, the third pseudocode, which uses a loop. So the program starts, then I do a work, the program does a work which is assigns the value 1 to the variable x. Then it prints x. So input output statement, so a parallelogram. Print x. Then it goes add 1 to x. So how it is a work statement, work box. Basically, it's not it's the actual term is a processing box. So these are processing boxes. These are processing boxes. These are start stop boxes. These are input output boxes. This is the processing box. Processing box. This is an IO box, and these are assignments, and these are the control flow, program control flow arrows. Program starts here and goes from top to bottom, right? Control flow, print x. Then I add 1 to x and store it in x. Okay, so where do I store it? I do x plus 1 and store it back in x. This is important. This is a very important step for those who are new to programming. You add 1 to x, you don't put it to some other variable y. Okay, you just put it back into x. Okay, now you have to print only till 5. So you have to check if the new value of x is greater than 5 or not. So if is x greater than 5, if it is yes, then stop. If it is no, then you go and join here. So if it is no, that means it is less than 5. So what will happen? Let us see. The program starts. X becomes 1. We print x, means 1 is printed. Then here it comes. X becomes 2. X plus 1, 2. And that gets stored in x. So x now becomes 2. So here I check, is x greater than 5? So just a second, I should have a little bigger decision box to make it. Is x greater than 5? Now whether you want to do it greater than 5 or whether you want to do it greater than equal to 6, or this is what should come from your mind. Okay, what is the condition I should check? So let's see. Initially x is 1, prints it, comes here. X plus 1 is 1 plus 1, 2. 2 gets stored in x. We come here after this processing box. This is a decision box. We check, is x greater than 5? No, x is 2. So no. So no means we come here and here and join the arrow here and come here. So we print 2. Then we come here, 2 plus 1, 3. 3 gets stored in x. X is 3. Come here, x is greater than 5? No. We come here, print 3. X becomes 4. Greater than 5? No. Print 4. Come here, x becomes 5. Is x greater than 5? No. Come here, print 5. X becomes 6. Is x greater than 5? Yes. Program stops. Right? So here a set of statements. These set of statements repeat again and again until some condition is true. So that's why it's called a loop. And you can pictorially see that it actually is a loop. Loop is something which goes in circle, right? Loop. So that's what it is happening. It is a loop. If I just think about it, this green line. Complete loop, right? Now, any questions before I give you some um, work to work on? Any questions, anybody? Okay. Louis has asked something. Um, Sequence will Python take by default smaller to bigger, or we need to specify? Um, can you just sequence means which sequence?
So for numbers and for alphabets, will Python by default know that it is A to Z first and 1 to 10, or we need to uh, uh, code it specifically that we need in this way? One should come first, two should come second, like that. Or does Python by default know
Okay.
that this is the sequence?
Give me an example, because I have not yet fully understood the context. I understood what you are saying, what you are asking, but in what context? I mean, give me an example so that I can discuss it. I mean,
So
like,
the pseudocode 3 was discussing print
which pseudocode?
A, B, I think 2, where you were given A, B, A is 1, B is 2, this one. So here, when you say print A to, if we say print A to E, uh,
No, I did not say print A to B anywhere. I individually wrote print A, print B. Okay,
okay.
so I could have called it uh, ABHIJIT, and this I could have called it Viswas. Okay, I can give any name to a variable. Okay, and this cat and this is a dog. Variables can be given any name. Python doesn't make any logical interpretation on the name of the name of the variable.
Okay. Okay. So in this example, we need to print each variable individually.
Yes, yes, you have to tell that, because I wanted you to print from A, I mean, sorry, from 1 to 5. So 1 should print first. So which variable I have put 1, that I would print first. If you just look at the pseudocode, I wrote print A and then I wrote print B. Python only knows one thing, or every programming knows only one thing, that it has to go this way. This should come, this statement first, this statement second, third, fourth. So see, sequentially the programs will be executing. I mean, the statements will be executing. If I write print B here and print A here, then it will be a problem. It will print 2 and then print 1. Got it?
Okay, sir. Yeah, got it. Thank you.
Okay. So whatever sequence I have to print, I have to print them in that sequence, the variables. So A and B, and mind it, I wrote these obnoxious names just to show that, uh, I mean, these variable names have no meaning to Python. Okay, you can give any name to your variable. You can call them Calcutta, Delhi, Bombay, Madras, Chennai, whatever. Chennai is 1, Calcutta is 2, and Mumbai is 3. Fine. Okay, so you can call whatever. You can give any name to your variable, but there are a few rules when you give names to variables. Variable names cannot start with a number. Okay, so let me variable naming rules. Any language, this is true for any language. It it cannot be the keyword of that language. It cannot be a keyword. A variable name cannot be a keyword of that language, whichever language you are writing your code. So if you are writing in Python and you want to name a variable called if, no. If is a keyword and your variable cannot be called if. Or is a keyword. In is a keyword. You cannot give names to variable using keywords. Second, um, second is names cannot start with generally in most languages cannot start with a number. For example, you can give a variable name like uh, alpha. You can call it. You can give another a variable name called alpha 1 or alpha 10, but you cannot generally call it 10 alpha. You cannot give these kind of names. Okay. If, or, in, etc. not allowed as variable names. Okay. They cannot start with a number. Third is um, cannot contain a space. The variable name cannot contain a space. So you cannot name a variable like my name. No. This will be treated as two different variables. So if you want to put a gap, just put an underscore, my underscore name. So this is allowed. But my and then space name not allowed. Okay. Similarly, there are a few more naming conventions depending on the language. Other than that, you can give any name as you please to your variable. And just that, generally variable names are restricted to 255 characters long. Okay. Names. All right. Right? Yes, of course. I will be putting um, flowcharts and pseudocode examples for you to work on. Okay. So, let me just answer the questions. So you have asked sequence will Python take by default smaller to bigger, or we need to specify? As I mentioned, the sequence, this I have answered, right? Okay, and Nachiket, you have asked, could you give more examples of flowcharts and pseudocodes? Yeah. So now, task. Third problem. Um, print all odd numbers from 1 to 100. Fourth, Um, mm, Print all even numbers from 1 to 100. Fifth, print um, the sum of all numbers from 1 to 10. Sixth, print the sum of all numbers um, no, print the average of all numbers from 1 to 50. Okay, so write these pseudocodes and bring it tomorrow. All right, so we will wrap up for tonight. So this was an absolutely ground level session, but I wanted to take an extent this I want this programming sessions that I want to take. I want to take it thoroughly from ground zero, from scratch. Okay, so that you can gradually develop. For those, this is meant for those who are absolutely new to programming. So you can gradually develop your logical programming, programmatically thinking, um, programmatic way of thinking. Okay. So any questions? Yeah, this video will Ritish will upload tomorrow morning.
Mm-hmm.
I think um, you should be able to upload by maybe 11 or 12 or something. Okay, I'll just inform him. All right then. So I'll wrap up this session for this evening. So good
Yeah,
night,
yeah.
everybody.
So,
Yeah, anything else you want to ask?
yeah. Just one question.
Uh-huh.
How many sessions do you plan to take like this?
Um, it depends on the pace that you would all would be um, uh, comfortable with. Okay, so if it requires whatever number of sessions to develop these the programming skills, I have kept it open.
I see. Okay.
As of now, I have kept it open.
Okay. So I don't know about others who would look at it at the in an offline manner, and
Mhm.
couple of people who are on the call, what are their thoughts? But I felt this could be more quicker in a sense.
Okay.
This was extremely basic, and it's good. I mean, for,
Yes.
if someone is benefiting, it is nothing like it. But that's what I felt.
Actually, the pace will quicken up because what happens is at the beginning you need a little slow pace.
Yeah.
Once
That is correct.
once your mind starts, on that track, on the programming
Yeah.
track, then the pace picks up like anything.
Because the thing is, learning programming is one aspect, and the other one is using those tools and some tricks and etc. etc. Which
Right.
is
right,
altogether a different thing.
right, right, right,
Like using an environment such as Spider,
right,
that is
right,
another thing. Yeah.
right.
So for me, that is the place where I would like to know more.
Okay.
And some of the tricks
You
such
just
as
can ask, no, you can
sorry.
just, whatever your requirements are, feel
Mhm.
free to, post it to me. Okay, that
Okay,
this is what I
sure.
want, this is what I want.
Okay, okay.
Okay. And as I was saying, yes, two things. Yes, tools. They programming. This is what we have discussed is not specific to any programming language. This is
Correct,
general
correct,
basic base
correct,
to all kinds of programming languages that are there. Then we pick up
correct, correct.
Python. Now, when we pick up Python, then we get specific and we'll take up one of the environments, whichever is comfortable.
Correct,
Jupyter Notebook
correct.
is also quite comfortable. Okay, and if nobody has any issues with that, then we can use that. And the other thing is, pace generally would pick up. Pace generally picks up
Mhm.
as we go along.
Okay, yeah,
So I don't suppose this is going to be more than what? If we have, let's say, today was like very slow. Okay, this is a 1 hour
yeah,
program which I completed in 2 hours. Okay, not even an
correct,
hour program actually. Okay, so if I consider it this, so this might be a 10 session, 7 session.
correct.
Um, and then what happens is Python, if we go a little bit into the libraries like the NumPy and the Pandas a bit, okay, so there might be a few sessions there. So
Yeah, I sat through the whole thing simply because what I've learned is that, let's say there are 10 basic things, and most of the time you think that you know everything, all basic is done, there is no need to learn. But somewhere, some in some corner, some basic fundamental remains loose. Out of that 10, you may have known 9, but one remains as a weak link. So I thought there's always
okay,
value addition
okay.
going through everything.
Yeah, Uday, actually, I was surprised that you were here because
Yeah.
I did not think you would be there.
So I'm here simply because there has been a huge gap of programming. I did programming 20 years ago in Fortran, Pascal, Basic, and then the
Right.
entire career elapsed. And now at the end of the career, having not done any programming, that is where I'm struggling. But
Okay,
I've
okay,
written,
okay.
yeah, I've written codes in numerical methods in Fortran programming and all those kinds of
That's
things
fantastic.
during my engineering days.
Yeah, I understand. I mean, like that must have been 20 years back.
Correct. And then all the programming that I learned a little bit was COBOL, and then simply went into non-programming career, and now
Right,
back to this.
right,
Correct.
right.
Yeah,
For you, it should not be difficult to pick up because you already have been through all. If you have done, let's say, Fortran or
yeah,
COBOL,
correct,
I
correct,
mean, nothing like it.
correct,
So, and that's why I said I was a little surprised that you sat through
correct.
this
Yeah.
this
Sad through simply
very
because I know, because I like to brush up everything to perfection, and I think you take things in such a nice and a detailed and basic manner with anyone who has I think any doubts, queries, everything gets resolved. So, so,
okay. Thank
so I
you.
love that, and that's the
Thank you.
reason I thought I should not miss this.
Pleasure. Thank you. And
Because
do feel
especially
free
that
to,
PyC and the executable and the
uh,
compiled bytecode and all, those were
uh,
the loose areas that were there in my case. So I learned that. So there's always
okay.
learning.
Right. Actually, why that would be a gap area is because this bytecode thing and all the thing was not there when you had been coding.
Correct.
Okay.
Because there was no interpreter. I used to compile and look at the
Yes.
E for error, W for
Yes.
warning, I for information, and all those things.
Yes. Yes. At that time, these are let's say over the last 15 years, these things have picked up because like just think about Python. Python is not a new language. Python is a
Yes.
very old language. I mean, not
Correct.
very, okay, old language. Okay,
Old language.
but this was always an interpreted language. But
Yes.
what happened is nowadays Python gets used so much,
Yeah.
and this was slow. Okay,
Correct.
so this had to be speeded up.
Yeah.
So this bytecode thing or intermediate and actually different companies call it by different languages. For example, in under this .NET framework in Windows,
Mhm.
it's called
Mhm.
managed code. Okay,
Mhm.
either native code. Native code means fully compiled, zeros and ones, or partly compiled managed code. So these terms
Mhm.
would have come after you left programming actually.
Correct.
So that is
Correct.
why, yeah,
Correct.
these things.
Correct. Correct.
Yeah.
Perfect.
So I just wanted to add some stuff, sir.
Uh,
So basically, I just wanted to tell that this particular programming is very new for me. Like the phase which is going is okay for me. I mean, if it is, I mean, like for Uday, sir, it might be a very, basic. So I mean, it might be very basic for him, but
okay, let
for
me put it like this, Nachiket.
yes, sir.
Uh, the main flow of the algo course. Okay, don't worry too much about it. Okay, don't worry too much about it because uh, as you learn this particular programming, the basics, and you have the second part coming, right? The second part of the program coming. So you have time to revisit these algorithms, these programs. Once you are through with the logics, okay, then you will see that you are able to pick up, and I will anyway be guiding you. So once you are comfortable with what we are teaching, these basic programming things. Once we are through with this, then I will help you with uh, revisiting the codes that we are now writing. The codes that the algo codes that we are now writing, we are going at some pace. Although um, I mean, I don't think we are going slow, but we should be going a little bit faster. But what I mean to say is, I will revisit the codes with you, and once you are through with this basic programming stuff, you should be able to pick up those codes. Okay, I will run you through those codes again.
So I
Okay,
just
so
want
once we finish this, we'll we will have these evening sessions. Okay, where we pick up the code that we write in our Saturday Sunday classes, and we revisit. Got it?
to. I mean, the basics itself is something which is actually I'm getting success. So I just asked if they said to about this problem.
Mhm.
If today, so like as an experienced person, if he is going to see this video, I mean,
Nachiket, your voice is fading away, so I'm not able to hear what you are saying. Maybe you can call me
yes, sir.
tomorrow during the day because I think we can wrap up the session this evening session, and you can have a look at the video tomorrow. We'll just post it in the morning, and you can call me.
Uh, yes, sir. Just last comment from me. I am finding it very useful, sir. The
Okay.
pace and this additional effort, I
Okay.
really appreciate it. I am finding it more useful than the Python videos initially shared. So I think
Sure.
this will be
Thank you.
very helpful.
Thank you.
Thank you, sir.
Thank you.
Good night.
Thank you. Okay, then. So we will wrap up this evening's session. You can watch the video of this recording tomorrow. We'll tomorrow means this is like 10 o'clock India time. So maybe around 10 in 12 hours time you can have a look at it. All right. Thank you, guys.